you do the integral, it's going to be the opposite, right? So instead of multiplying by 2 like we would with derivative, we do the opposite, we divide. 1 over 4. I don't know if that helps you remember. If it does, great. If it doesn't, sorry. Plus C, indefinite. If it goes off screen, let me know. Yell at me. Okay, next one. We have the integral of x over x squared plus 9. Okay, so this could go one of two ways. You can either do a U-sub or you can do a trig sub. Trig sub is sometimes the most easier. I wonder if this one's the most easier. So actually, in this case, U-sub is easier. I'm going to do them both, but you'll see both. So if we want to do U-sub, then U would be equal to x squared plus 9 du 2x dx, right? 1/2 du is equal to x dx. So therefore, we have 1/2 du over u. This is equal to 1/2 ln of x squared plus 9 plus c. That's not so bad. Trig sub's harder. That's okay. Okay, let's do it again. But with trig sub. We have x squared plus 9 dx. We want to do trig sub. Okay, so we have our forms. We have a squared plus x squared, a squared minus x squared, and then x squared minus a squared. Plus tan. Both look like pluses. Minus sine with the variable. Minus a is secant, yeah. Okay. We're going to be using the plus, so tangent. This should be the easiest one to remember. Don't get it wrong. Plus and t look very similar. Okay, so if that's the case, then I know x is equal to a tan theta. Well, a is the root of whatever that plus constant is. So that is root 9 tan theta, which is really 3 tan theta. I saw a hand. Does that mean someone has a question? Yes. Sorry, what? Oh, to do trig sub. I'm currently doing the trig sub right now, so I do need a square root on my constant 9. This wasn't a formula. This is like what goes with what sign when you see at the bottom. We do not need a root. Oh, you mean here? Do we need a root to do trig sub? No, we don't need a root to do trig sub. We can do trig sub anytime we want to. It's just most convenient and best for us to do a root. That's usually when, like, before U-sub worked, if you have a root, that kind of makes that harder. So, but you don't need it, which is a good thing to know, right? You don't need a root here. That doesn't need to exist all the way across to make it happen. So yeah, good question. Okay, so we have 3 tan theta all over 9 tan squared theta plus 9. Yeah. Okay, so we have sine plus cosine is equal to 1. If we want tangent, divide all by cosine. Tangent plus 1 is equal to secant. If I pull out a 9, 3 tangent theta, 9 tangent squared theta plus 1. Therefore, it's a secant squared. 1/3 tangent theta, secant squared theta. I still need to find d theta. I can't just plug that in. So we need to find d theta. So dx is equal to 3 secant squared theta d theta. So that should have been up here. And here, and here. I'm going to rewrite it because I forgot it. And I'm writing with a Sharpie. No one caught me or said anything. Come on, guys. Like, I'm performing in front of you guys doing calculus 2. I'm going to make mistakes. You're sitting in a crowd of people, protected by the masses. Okay. This makes it a lot easier. The secants cancel, the 3's cancel, we're left with the integral of tangent theta d theta. You should know that. It's okay if you don't. It is not secant tangent. Yeah, it is not secant tangent. I don't think so. But you can always prove it yourself. This is U sub. U is equal to cosine theta. Du is equal to sine theta d theta. So you have 1 over u du. That's natural log of cosine theta. Yeah, because this guy's negative. This or this guy's negative. Therefore, this guy's negative. So yeah. So natural log of cosine theta, which is natural log of secant. So not natural log of secant plus theta. It's not the natural log of secant plus tangent, which is the derivative. It's the integral of secant. Anyways, so y'all are laughing at me. Okay, so x is equal to 3 tangent theta. We need to find out what theta is because everything needs to be in terms of x's. Don't leave it in thetas. That's not the final answer. I know it looks pretty. I know you want to stop. Don't stop. X over 3 is equal to tangent theta. So you learned in grade school, SOHCAHTOA. It comes back to haunt you today. TOA means opposite over adjacent. The H is always over hypotenuse. So if this is my theta, this is my opposite. Well, what it goes on opposite is x, 3. X squared plus 9 roots. Triangle. I want to find out what cosine, tangent inverse, that is, right? So what's the cosine of this angle? Well, it's adjacent over hypotenuse. Negative ln, adjacent is 3 over x squared plus 9. And that's sufficient. Your answer will be slightly different if you push the negative to make the inside, so it's ln of secant. Your answer will be flipped, and the negative will be gone. But that's okay. Any questions? Okay. Are these pretty easy? They're supposed to be kind of easy. Okay. Let's keep going. We have 1 over x, 16 minus x squared dx. How would you like to solve that? Trig sub. This is an obvious trig sub. You can't, like, not do, I don't really, you can't not do trig sub. So, if we're going to do trig, the negative's in front of the x, which means we do sine or secant? Sine. So, (16 minus 16 sine squared theta). And then I have to replace dx for cosine theta d theta. Okay, my 4's cancel. And then I have a 4 pop out. I'm not going to skip that many steps, but it happens. Cosine theta d theta over sine theta, 16 times by 1 minus sine squared theta. Okay. This becomes a 4. It comes on the outside. Cosine theta d theta, sine theta. Sine plus cosine is equal to 1, so cosine is equal to 1 minus sine. So then this becomes cosine squared under a root, which is just cosine. Cosines cancel. You have 1 over 4 cosecant theta d theta. I already have the d theta there. Okay. This is one of the ones you have to have memorized. It's the natural log of cosecant theta plus cotangent theta plus c, I believe. It's been a while. Negative. Why does that, I keep missing my negatives. That's going to happen for the rest of this session. If there's ever a discrepancy, it's probably because I'm missing a negative. But yeah. And then we're not done, because this is what? Thetas. We can't stop at thetas. So we need to go forwards. X is equal to 4 sine theta. So x over 4 is equal to sine theta. Triangle. Opposite is x over hypotenuse, which is 4, which means if I have x squared plus some constant I don't know equals 16, that means a is equal to 16 minus x squared. So I would have, I'm going to do it down here, ln of cosecant. So cosecant, right, is the inverse of sine. So instead of being opposite over hypotenuse, it's going to be hypotenuse over opposite. So it's going to be 4 over x plus cotangent, which is going to be adjacent over opposite. So that would be 16 minus x squared over x plus c. Questions, comments, concerns? I'm like super blind, so if you have a question, you're raising your hand, and then I don't call on you after I say I don't have any questions, it's because I didn't see you. And you should just yell at me and be like, I have a question. I'm not going to be offended. Okay, so that's that. We're going to move on to series. So we're going to find the interval of convergence and the radius of convergence of a power series. Oh my gosh, power series, they come back to haunt us. Okay, so power series.
Move it down a bit.
Yes, absolutely. Thank you. That's a good yell.
Thank you.
Of course. Okay, so ratio series. Not ratio series. That makes no sense. Ratio test. We're going to do ratio test on this guy because he's power series, and then you want to find the interval and the radius. So if we want to do ratio test, we take the limit as n goes to infinity for a n plus 1 over a n. Absolute values. Memorize. Not this, memorize it from your notes, because like anything I say or do may be potentially wrong, because again I'm performing math in front of you all, so please go back and double check. I did my best to make it accurate. I even wrote down answers beforehand so I wouldn't make as many mistakes, but you know, things happen, like negatives. Plus 1 times by 2 to the n squared x to the n. And I forgot my limit. Limit. Okay. Okay, so this guy kills every one of these guys. We have 1x left. And this guy kills every one of these guys. We only have 1, 2 left. So we have the limit 4 n squared plus 2n plus 1 times by x divided by 2 times by n squared. Divide the polynomial by n squared all the way across. If you do top and bottom, you're technically dividing by 1, so everything is still okay. And you end up with 1 plus 2 over n, 1 over n squared, over 2 times by x. You put the infinity all the way through, you get 1/2 x. How do we know if a series is convergent with ratios test? If it's less than 1. We need to find out when this bad boy is less than 1. Okay. So 1/2 x needs to be less than 1, or negative 1. Multiply both sides by 2. Let me double check before I make a declarative statement. We are good. Therefore, the radius of convergence, right, from -2 to 2, well, the total distance is 4. Therefore, just half the distance is 2. That's kind of obvious in this case. It's not always going to be obvious. So the radius of convergence is going to be equal to 2. The interval of convergence is from -2 to 2. We have to check bounds. We can't just automatically decide they're either convergent or divergent. So let's do that. We have our original series of n squared, 2 to the n, x to the n. But we have x's this time. This time, x is going to be to -2. If x is to the -2, that means that we have a series for 2 to the n, -2 to the n. This simplifies. We get n squared, -1 to the n. This is alternating series test. But we can kind of just look at it and tell that it diverges, because it doesn't, like, you can't say the alternating series test, like, fails, but it doesn't, like, because we can't use it, you don't have any other tools available to you except the absolute series, and if you do the absolute series, it diverges. And it's easy, you can say it diverges. Because I say so. You can do the test for divergence. That's the test that you use. I'm like, I don't know what test I use. I just was able to look at it and tell. And I'm like, I don't know. Because you use the test for divergence. If you do the limit, thank you so much. It's just infinity. Or not. It's negative infinity. It bounces. It doesn't work. Like, no matter what you do, I don't know if you can do test for divergence because it's not positive. I want to say you can, but I could be wrong. Regardless, it doesn't work. No matter what you do, it fails. It diverges. And then in the same vein, if this guy's positive, it still diverges. So I used a test on it, and I forgot what test I used. And like a fool, I didn't write it down. So I'm just going to move on. I don't have time for that. You have a series of tests that you can use. Go through that. Okay, you want to do the Maclaurin series of the next function. Oh, any questions on the previous one? No? Yes? Okay. So, we want to do Maclaurin series of this function. Cosine x. And we want to find the radius of convergence for that series. So, this is Maclaurin series, so our A is going to be 0. Beautiful. Okay. 0, 1, 2, 3, 4, 5, 6 should be sufficient. I know it's an even function, so I don't really, like, Okay, so derivatives. Cosine x, negative sine x, negative cosine x, sine x, cosine x, negative sine x, negative cosine x. How'd I do? I think I did okay. 1, 0, negative 1, 0, 1, 0, negative 1. Plug in zeros every place you see an x. Cosine of 0 is 1. And negative cosine of 0 is negative 1. Life is good. Okay, you have a formula you need to have memorized that we plug it into. This is your Taylor series formula. Maclaurin series is Taylor series, but your A is 0. So you can use the same thing. If A is 0, right, this guy doesn't matter. And you already know what these guys are. So we have, move it down. Because I was going to write like right here. Can you see that? You can see that. Okay. So we have n over 0 factorial times by x to the 0 factorial. No, sorry, times by x to the 0 plus 0 and stuff. I don't really care what it is. It's just a squiggly. Like, it doesn't matter. Then next one, negative. Negative 1 times by, well, our n now is 2, right? So we have x to the 2 over 0, 1, 2 factorial plus 0 plus 1 x to the 4 times by. 4 factorial plus 0 plus negative 1 times by x to the 5 6 over 6 factorial dot dot dot. It keeps going because it's a series. It goes on for forever because it says so right here. At every odd one, it's 0. So I can ignore those. I know 2 factorial, x to the 4, 4 factorial, x to the 6, 6 factorial, x to the 8, 8 factorial, so forth. It continues, infinity. Yes. Thank you. That would have been bad. Okay, so let's take it apart. I know that it's alternating because I didn't miss any infinities for some mysterious reason. It's not like I had help or anything. So if I create a new series and I want to start it at 0, and I know it's alternating, what power must I start at to make the first term positive? N. If it's n plus 1, that means it's odd. And then we just have negative 1 to the first power, which is negative 1. If it's to the 0th power, right. Okay, so next thing we have to take care of. We have to take care of x. Okay, so x goes from 0 to 2 to 4. We're increasing in terms, and it's even. So let's say it's 2 to the n. If it's 2 to the n, then it starts at 0, and now n is 1. So it's raised to the 2nd power. And now n is 2, so it's raised to the 4th power. Life is good. Well, if the factorial is going to be the same thing as the exponent, and we already figured out the exponent, life is good. Okay. Another one. How are y'all feeling? Okay. Okay. We're going to find out if the series converges or diverges. Does the series converge, diverge, or conditionally converge? Well, it doesn't alternate, so don't even look at conditionally converge. Like, just wipe that out of your head. It's not a factor. Okay, so this is root test. You will very rarely do root test. Today is one of those occasions where you will rarely do root test. It is the limit of root n, a to the n. If this is less than 1, then what? It converges, and life is good. Okay, so we do the root test. We take the limit. Limit is n approaches infinity for n over 2n plus 1, absolute values. This is equal to 1/2, which is less than 1. So it does converge. N factorial, e to the n. Converge, diverge, or conditionally converge. We see a factorial, so it screams ratio test. Every time you see a factorial, always do ratio test. Yeah, pretty much. So the limit as n approaches infinity for n plus 1 factorial, e to the n plus 1 times by e to the n over n factorial. Absolute values. We end up with limit as n approaches infinity for n plus 1 over e to 1. It's going to be e to the first power, which is just e. That's equal to infinity. I did something very wrong. N plus 1. This is fine. This is fine. Oh, yeah. So it's equal to infinity, so it's never less than 1, so therefore it does what? It diverges. Okay, I'm good. And yeah, this is e to the 1. I wrote an n out of habit, and then I was like, wait, it's not 1n though, it's 1. So that's a scribble, and then that's 1. Okay, I have a really good problem for you guys. Only one of you knows what it is. Yeah. Does the sequence converge or diverge? Yes. Thank you. Does the sequence converge or diverge? I'll give you a couple seconds to chew on it. You're not going to learn unless you fall flat on your face and you're like, oh, I should have known that. So series, we use tests. And we have the divergence test. And we go, hey, if I take the limit of this guy and it doesn't equal 0, it equals like 5 or infinity or something, then I know that it diverges. Sequences are different. Sequences just need to converge to a number. If sequences converge to 5, then you're good. So let's take the limit and see if it converges or diverges. Okay, if I plug in infinity, I'm going to get infinity raised to the infinitieth power. Your calculus 1 professor screams in his head, don't do it, because you can't.
That would mean n equals 0.
0? Yes. Still don't do it. Doesn't make a difference. It's not 1. Infinity to the 0 is not 1. Never, 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 never 1, because I say so, because all professors say so. Some professors will even argue that this is not 1, and some argue that it is, and there's a huge debate about it, and it's really fascinating. We're not going to get into that here. But it just exists for your fun reading after the finals, in case you want to relax, because this is what you want to do when you want to relax. Okay, so it's infinity to the 0. You can't do it. You have to do L'Hopital's, but you can't do L'Hopital's because there's not fractions. It's an exponent. You have to manipulate it. How do we get exponents down in front? Logarithms. Well, whatever I do, I have to immediately undo because I cannot change my value. So e to the ln of n to the 1n. Take the limit. Limit as n approaches infinity for ln of n over n e. It's easy. This is infinity over infinity, which is kind of what I was kind of thinking about before when I was like, it's infinity to the infinitieth power, and it's like, no. So we can push the limit up because Calc 1 rules. And then ln of n. This is L'Hopital. I don't know how to pronounce it. Don't mock me. I hear laughter. I know who you are. Okay, derivative of the top is 1 over n. Derivative of the bottom is 1. You're stuck with that. That is 0. So therefore, it converges to e to the 0, which is 1. So a lot of people will say that it converges to 0. Don't be that person. Don't forget your e exists. He has a life, he has a family, he has a job. You can't ignore him. Okay, that's a fun exercise. It is at 1, right? Therefore, your sequence converges, because it's a sequence. If your series does this, then it diverges by divergence test. Don't get confused. Okay, next one. We're going to find the radius of convergence for, let me check the time really quick actually. Move it up, down, yep. We started at 3:30, right? So it ends at 5:30, so we're good. So then it would be n squared, 2, 3 to the n, x plus 4 to the nth power. We're going to find the radius of convergence on this thing. Okay, power series, ratio test. They should be associated in your mind like chocolate and happiness. Talking and writing is really hard. I have to focus. It takes all my concentration. Does that look good? Someone laughed. Is it that bad? What happened? It wasn't me? Okay, good. I was like, oh no, it's so wrong. They're laughing at me. Okay, so if I take the limit, I'm going to end up with x plus 4 over 8, which needs to be like to converge. My radius of convergence is going to be 8. Yeah. So, and that's all the question asks you to find. If you wanted to find the interval, again, you'd be like, hey, okay, so multiply both sides by 8, subtract 4 on all of the things. You'd end up with 4 and negative 4, or something of that nature. It's not fun. I don't want to do it. It's plug in values and see if it converges or diverges, and you guys know that. And there's better things to do. I'll come back to it if we need to. I have a lot of stuff to do. Okay, sequences, like sequences. Everyone can be that person. That statistic. Yes. You're welcome. Thank you for telling me. Okay, this is a sequence because notation says so. Also, your professor will probably tell you. If he doesn't, no, because of the curly braces. We want to see if the sequence converges or diverges. We take the limit. Right now, if you take the limit of this guy, I shouldn't have put that line there. That was a mistake. What do you get? Infinity. Is that a number? That person who says yes. It's not a constant number that we can specifically define and plug into a computer, being like, this is an integer, therefore it is not, therefore it diverges. I really like the really witty people in like my sessions because then they make my life more interesting. Not that other people don't, but I mean like they bring a certain spice to it where it's like you don't know what you're going to say to set them off, but they're going to say something and it's going to be hilarious and slightly humiliating. Okay. Does this series converge or diverge? If convergent, find the sum. This is what kind of series? Geometric. Beautiful. We have a geometric series, which means we have formulas to figure out, right? But first we have to figure out if it converges or diverges. That's not too bad. We have -5 to the n, 4 to the n. And you're like, but wait, you added an extra 5. That is true. I did. I also added an extra -1, in case you didn't notice. If we take it out, if we add it to the top, right, then we have to pull it out on bottom. We're good. Life is happy. That's not the form you learned, though. I'm doing the wrong form. That's okay. So, like, you have one where it's like n equals 1 and n equals 0, and that affects how things work out. I'm going backwards. Yours would be geometric is when n is equal to 1 for you guys, and then it's n minus 1 up top, so I have them backwards. So, I'm going to switch this, and now you're going to hate me for it. That's the form you guys learned. So for geometric series, a r to the n minus 1 is your form. You want to find out what r is, right? And then there's similarly an identical form. I mixed the two, but you should know them both. Your professor probably only wants you to know one, if you're lucky. So your 4n goes down, you pull out a 4. Yep, that's good now. I'm satisfied. No one's saying anything when I make these algebraic mistakes, and like, you're not in front of a camera, guys. Come on. So, you have 1 over 4, because if you multiply it in, then you get 4 to the n on the bottom, right? So that's good. And then the top stayed the same, so we haven't changed anything. Okay, so our ratio, right? Our ratio is negative 5 to the 4. Is that less than 1?
Why'd you divide it by 4?
Because I'm trying to keep this guy the same, and I messed that up. I should start over. I'm going too fast in my head. So I want this form. This is what I'm trying to match, right? And I don't have that right now. I have negative 5, n minus 1, 4 to the negative n, right? So if I push it down, I get 4 to the n. But that still doesn't match. I need that n minus 1. And to merge the two together, I need to pull out a 4. That's what I did. But I did it in like 8 steps, and I did it wrong twice because I'm stressed out. So it's like, aha, now you can totally clearly understand this material, right? No. If I ever do anything that's unclear, like let me know. I'm willing to go back and redo something if it was unclear the first time because I missed a negative and now that changed life things. So, yeah. Okay, so we do this. We know that R now is equal to negative 5 over 4, and A is equal to 1 over 4. Absolute value. Well, no, R is, yeah, R is that. But like we need to figure out like if it diverges or converges, and that's when we use absolute values. We say, hey, the absolute value of R, right, is 5 over 4, and is that less than 1? That's not the case, so therefore it converges, because it doesn't meet the geometric requirements. If it did converge, let's just pretend, if it did converge, use this formula. That's a requirement. Okay. Any questions about anything I've covered thus far? We're entering a new segment, so like if you have questions, comments, and concerns, now's a good time to let me know. Otherwise, we're going to segue into the other thing. You guys are simultaneously so super quiet and so very talkative. I don't know how you pulled that off. Okay. So the last time I did Calc 2, I did it with Dr. Swanson again. I did it in the spring semester, and the YouTube video is up on that on the Stark YouTube channel. The first 3 integrals are cut off, so I'm going to do those 3 again. And then I think I'm going to jump to the back and do the series I didn't do or something of that nature. So, you know, we'll do math. The first integral was really not that bad, actually. I was going to make it's really hard, and I'm like, no. We want to do that one. This is trig sub. So x is equal to 5 sine theta. Dx is equal to 5 cosine theta. Five to the 5th, sine to the 5th theta. 5 minus 25 times by 5 cosine theta d theta. The last time I did this, did I like forget to do add the dx on the end? I forget. Double check your notes if you're taking notes. I did. That should have been there, and that probably changed the problem a little bit. Oh well. I'll go back maybe. That needs to happen. And you didn't say anything. Wait a minute. Like you said yes, like you noticed, and then like you didn't like catch me on it. 5 sine. I'm going to start making purposeful mistakes. That would suck. I'm not actually going to do that. That was a joke made out of spite and bad joke. I'm not serious. That was not serious. Okay, so we have 7 5s. Sine to the 5th. Cosine theta squared d theta. Okay, same thing as before. We have 1 minus cosine squared theta squared sine theta cosine squared theta d theta. Is there a mistake? 1, 2, 3. Okay, that's good. No, do that. Like, I'd rather you be like, there's a mistake and be wrong than leave it alone and have there be a mistake. Like, by all means. Like, this is being recorded. Like, come on, guys. Help a girl out. Okay, so u is equal to cosine theta. Du is equal to negative sine theta d theta. Squared. And I have u squared du. Plus du. Is that good? You think my signs are wrong? From here to here? When I foiled? So if I have u squared, so negative 1, let me do it by hand then. I could double check. I don't think so, but maybe. So that would be 1 minus 2u squared. No. What am I? No. Yeah, we're good. Good, like, thank you. So negative, does anyone else agree that I foiled wrong? Okay. Maybe I should stop talking while I integrate. Someone actually said that one session. They were like, for a final exam review, they're like, you should talk less and write more. I'm like, okay. And then this integral doesn't belong. Parentheses, the d doesn't belong. Okay. I actually need this paper though to figure out what this theta and x's are. Did I do something else wrong? We're good. Life is happy. Okay, so u. U is equal to cosine theta. Okay. Negative 5 points. I think I'm going to take her advice and just do math. Okay. And then we need to take theta and make it x's again. Ooh, something happened. I spelled SOHCAHTOA wrong in my head. I don't know how that's possible, but. Okay. We want to find out what cosine is, so adjacent over hypotenuse. So negative 5 to the 7. I'm running out of room. Writing in Sharpie is hard. Don't judge me. And writing in front of people is hard. We good? Okay. We have an improper integral. Oh, none of the other ones had bounds. Are we good? Yeah, none of the other ones had bounds. Okay, so we have an obviously improper integral. Yes. Thank you. I know that must get aggravating for you. 2x. Okay. We have lots of things going on. Oh, we got time? No, we're still good. Okay, so we have the limit as b approaches infinity for b to 1. There's no other places where the bottom is like 0 or infinity, so we're good. Now we have x plus 1, x plus 2. We can either do partial fractions or we can try to do u-sub. I'm going to try to do u-sub because I don't hate myself that much. But you guys should learn partial fractions, choices. Okay, so partial fractions, recap. We have, if you have any kind of x power, it stays a constant because the first original power, right, was an x. If you have, this is linear. If you have generally a quadratic bottom, like x squared plus 4, it's an irreducible quadratic, so ax plus b. And then for every successive power, so you'd have cx plus d for the squared version and so forth. And then it continues. If you have a cubic power, you have ax squared plus bx plus c, and then so forth using letters of the alphabet. So let's keep going. If we wanted to do partial fractions, which is not my go-to, but we haven't done a partial fractions problem yet, then we would have and an itty bitty dx on the side. And that's really easy to integrate. We have a ln of x, absolute values, plus b ln of x plus 2, plus c. I learned. Okay. That's your integration part done. We still need to plug in bounds, so plus c goes away, 1 to b. Okay, so that's that done. Now I need to find out what a and b are equal to. I know that x plus 1 is equal to a, x plus 2 plus bx. 1 is equal to a plus b, and then 1 is equal to 2a. You all cool with that? It's okay if you're not. Okay. Therefore, I know that 1/2 is equal to a. Therefore, 1/2 is also equal to b. Because what else could possibly make a whole? So, I know that we have the limit as b approaches infinity for 1/2 ln of x plus 1/2 ln of x plus 2 from b to 1. Plug in b, take the limit, you'll find out that it's equal to 0 or infinity. Life is bad. The integral is divergent. Yeah. Questions, comments, concerns? Okay. We have another one. Any mistakes on the last one? Okay. I trust him. He's pretty smart. Thank you. What I should do is maybe like go upside down and then write letters this way. That would be super legible for you guys. Okay. So we have this guy, and we want to integrate. There is a problem. If we plug in 0, we get a negative number. But that's fine because it's actually a cube root. False alarm. It's the 4. If we plug in where x is 4, then the bottom becomes 0. We're dividing by 0, and life is bad. So we can't do that. We have the limit as a approaches 4 for x to a. Plus the limit as b approaches 4 from b to 0. I will. Good catch. Okay. That part's done. Now I need to figure out what side, right? So if we're heading at it from the positive side, right, then that means this is plus and this is minus. Concur? Or disagree? I think of it like a number line. I don't know if that'll help you guys. If this is 5, this is where the break is, and this is 0. This is the negative side, this is the positive side. Yeah. If I happen to have it confused and backwards in my head, then just flip the 2. I don't think I have it confused and backwards in my head. But just in case. Okay, I want to take the integral, but I don't want to do it with all the limit stuff going on because that's horrible. So I create a side work side. And I go, this is my side work. Don't grade it for notation. And then I just integral. U sub, u is equal to x minus 4, then du is equal to dx. So this becomes u to the negative 3 du. If I could draw my u's like u's. Power rule, add 1, divide. If I add 1, it's negative 2. If I divide by that, it's negative 1/2. U to the negative 2 plus c. Negative 1/3. No, because if I take the derivative of it, that will go backwards. I'm good. Yeah. Yeah. No, wait, you guys are confusing me. Your side work. Yeah. This is minus. Yeah. Oh. There we go. Yep. This is horrible and embarrassing and horrible in every way. It's still U sub. You guys will understand when you're doing what I'm doing, and then it's like I feel pity. Okay, so this is u to the 1/3 on the bottom, which is equal to negative du, which is equal to u to negative 1/3 on top du. Then we add 1, which is 2/3 on top, and then we divide on the bottom plus c. It's really a good sign though that you guys are catching all of that because these are common mistakes, obviously. And you guys are catching them. So it means you're more likely than ready rather than not. Plus c. And then we need to take the limit and plug it back in, right? So this is just our side work. We're not even. So we have the limit as a approaches 4 plus 5a. But we took care of our integral. So actually it's just 3 to x minus 4. From to a. Well, if I do that, then it'd be 3, 2 times by 1 minus 3 to a minus 4, limit. If I plug in my limit, it's slightly more than 4, therefore it's a positive number, therefore this sign doesn't change. So it'd be 3 over 2 minus 3 over 2, which is equal to 0. It happens. Okay, so the next side. Yeah, that's true. Never mind. Wrong class. So this is 4, and this goes away to 0, so it's still 0. No, it's 3 over 2. This dies. I'm going to grab a drink of water and refresh my brain, because it died somewhere along the way. I did a lot of things wrong. I'm kind of embarrassed. I dropped the 2/3 exponent. I did a lot of really bad things. I'm going to start over and cry afterwards. Okay. I swear I know what I'm doing. I swear I practiced beforehand. I swear I'm smart. Don't judge me. Okay, limit. A approaches 4 plus. I'm not going to drop it this time. It'll be good. From 5 to A. I'm having a bad day, obviously. Okay, so we're good. So it's 1. So it's 3, because it's to the power of 1 to the 3 halves. So it doesn't exist. And then this guy's 0. So it's minus 0. That part's done, right? We're good. So this is equal to 3 over 2. I know math. I got an A in DE. I can do this. Okay, so it's 3 over 2 from x minus 4, 2/3. This is B. From B to 0. It is 0, right? Yes, it's 0. We're good. Okay, so if I plug in B, it's 0. It dies. Minus 3 over 2, negative 4, 2/3. I don't know what that is. So then it would be 3 over 2 minus 3 over 2, negative 4, 2/3. Agree? Okay. That was more horrible than it should have been. We good? As minuses. Well, no, because I'd still left the minus there. B minus 0. So then it would be, if we had B, then this is 0 and it dies, and it's so 0. And then we plug in 0, so we have a negative 4. It should be flipped as in the wrong order. Okay? Because this is the first one, this is the second one. I'm pretty sure that's solved. We plug in B, we get 0 minus negative 4. Oh, no, we're good. We're good. Okay, anyways, we're wrong. There's something wrong. I'm going to move forwards because I hate this problem with a burning passion. So this one, they flip. Okay, so they flip. I don't think they flip. Because you plug in B, which is 4. 3 over 2, B minus 4, 2/3, minus 3 over 2, 0 minus 4, 2/3. This is 0, minus 3 over 2, negative 4, 2/3. Like, we're good. I haven't forgotten to add yet. Okay. I'm kind of scared to keep going. So let's do, all of these ones are covered in the other video, except for the series one. Determine if the series converges or diverges. I don't like writing with a Sharpie. So do A. While I double check. It is backwards. you're talking about. Okay. Yeah. That's sufficient. 4 minus. So math is right, calculus is not. That would be from, so we have to do the bounds. The bounds are wrong. I'm not even going to try it anymore, actually. But the bounds are wrong. And if you flip them, then you get the positive version. And life is good and not terribly depressing. If you start at 0, you go the other way. Okay, so this one, you should have gotten time to do the other ones. So then you have six divergence test. Off the bat, you get 1/5. Negative 1/5, this is not equal to 0. It diverges. Okay, the other one is ratio test. 5 to n squared. Ratio test. I know, bad day. Sorry. So, if we want to do the limit as n approaches infinity for 5 to n plus 2 over n plus 1, infinity by n infinity, 2n, we end up with 2 5s left over and n plus 1 in the bottom. Which is equal to 0. So it's always convergent because it's less than 1. Okay. And you guys can see. Number 10. Does the series converge absolutely, conditionally, or diverge? What test do you guys use? Alternating series test. What do you have to prove when it's alternating series? So, let's do that. And let's zoom out other way. Okay. Is it fuzzy? Okay. Alternating series test, we have to prove that it's decreasing, and we have to prove that the limit goes to 0. If we take of this series, we divide top and bottom by n squared. We get 1 over 3n plus 7 over n squared. This is 0. First condition is met. If it does not equal 0, it diverges by divergence test. So that's your first condition that you should probably do. Okay. Now you want to prove that it's decreasing. You want to use the first derivative test. So take the derivative of the top, 2n times the bottom, minus derivative of the bottom, times the top, bottom squared. This is called quotient rule. If you've forgotten, you should look it up. Okay, the bottom is always positive. We don't worry about that. We want to find out where our derivative is negative. So the question becomes, where is this guy less than 0? If we distribute this, we get 6n to the 4 plus 14n minus n to the 4 less than 0, which is really 14n minus 3n to the 4 less than 0. So then we have 14n less than 3n to the 4. What do I want to do? We can, 14 is less than 3n to the thirds. So long as n is greater than 14 over third cubed, we're good. It's decreasing. Well, as it approaches infinity, it most definitely surpasses 14 over 3 cube root. So this condition is met. It is decreasing. If it's decreasing and the limit goes to 0, then by alternating series test, our series does what? It converges. And life is good. Okay. So, solve this series. Does it converge or diverge? What would you use? Integral test. If we use integral test, yeah, this needs to be x. Okay, so u is equal to ln of x, du is equal to 1 over x dx. We're left with 1 over u cubed du, which is equal to derivative of u negative 3 du, which is equal to this plus c, but what's u? Ln negative 1/2 of x to the negative 2 plus c. This is the indefinite side work part because we need to find out our bounds. This is side work. We want to find out the limit as a approaches infinity for, why do I keep drawing lines? Negative 1/2 ln of x, negative 2 from 2 to a. If that converges, that integral, then what? The series also converges. So we have negative 1/2 over 1 ln a squared minus plus 1/2 ln 2 over 1 squared. The first part's a constant. I don't care about it. This guy's what I care about. As a approaches infinity, what happens? 0. It goes to 0. We have 0 plus a constant, which is equal to constant. Therefore, our series converges. Okay. We good? Let's do another one. Let's do where's 13? To do integral test, you have to prove 3 things that I forgot to do. And you can't forget to do it. Okay. So for integral test, you have to prove it's positive, you have to prove it's decreasing, and you have to prove what? It's continuous. Is there ever a point at which n from 2 to infinity is negative? No. And there's ever a point between ln n from 2 to infinity is negative? No. So it's always positive. It's decreasing. You have a constant over an increasing denominator. By definition, it's decreasing, which leaves continuous. Is there ever a point at which the denominator breaks, right? We're dividing by 0, or we have an ln of a negative number, or ln of 0, any of that sort of thing. Well, we go from 2 to infinity, so the denominator is never 0, and ln of 2 is a positive number, and we never go below that, so you don't have to worry about it. So it's continuous. So it matches all 3 characteristics. You have to do that to use the integral test. You cannot forget. Okay. So you're given a sequence. Where are you kind of lost? Does the sequence converge or diverge? Okay, so we know it's an alternating series. We can choose where we want to start. I'm going to say 0. If we start at 0, and it's an alternating series, that means -1 is power. N, beautiful. Now we go from 1, 2, 3, 4. We can assume 5, 6, 7, 8. So it's an increasing power, right? N plus 1. Multiply that in this way as n increases, so does everything else. Let's just leave the bottom. 5, 25, 125, 6, 25. Those are powers of 5. So we have 5 to the n plus 1 power. Pretty good. This is a sequence, though, so I'm actually going to go like this and pretend that I got it right the first time. This is our sequence. Does the sequence converge or diverge? We have to take the limit to find out. Take the limit as n approaches infinity for -1 to the n plus 1, n plus 1. Okay. So there's a problem, right? We have infinity on top and infinity on bottom. We should do L'Hopital. L'Hopital's not fun in this case, but that's okay. We can do it. These are x's. X plus 1 over 5x to the power of x, 5 to the power of x plus 1. We want to take the derivative of that. So we want to do L'Hopitals on that. So then we take the derivative of the first, which is going to be 1, and then derivative of the bottom. 5x plus 1 ln of 5. Well, if you take the limit as x approaches infinity of f of x, which you'd use L'Hopitals on, you take the limit as x approaches infinity for 5x plus 1 ln of 5. That's equal to what? 0. So our sequence goes to 0. Therefore, our sequence does what? It converges. Okay. So that's that. Let's do more. Okay, so let's do x to the n equals 1 to the n root n x to the n. Does this sequence converge, diverge? What's the radius of convergence? What's the interval of convergence? Go forth and solve it. It's power series, so we want to do ratio test. Take the limit as n approaches infinity for 2n plus 1, n plus 1, root n plus 1, times by x to the n plus 1, times by n root n, 2 to the n, x to the n. Absolute values. Top part's not so bad. Bottom part's kind of scary. Absolute values. If you take the derivative, do the L'Hopital's rule, you'll find that the n's all cancel out with each other, and life is good. So you're going to end up with this being equal to 2x. And you want to find out where that's less than 1. our radius of convergence is 1/2, right? It's 1/2. Did I move it up? Lower. Yes. We want to find out if our bounds are convergent or divergent. So we have -1 to the n, 2 to the n, 2 root 2. Which converges by AST, though this is an n. The limit goes to 0, and it's decreasing. You have the other bound. That's equal to 1 over n root n. It's greater than 1, so it converges by p series. So you're going to use brackets. Yes. You good? Okay. So let's do finding power series. Your professors are probably going to ask you, hey, here's a function. You should turn it into a power series for me so we can get an approximation. And it's going to be a sad day. So let's do that. If we have 1 over this guy. Yes. Yes. You're welcome. Okay. We want to take this guy and have him match the form, right? So it should be 1 over 9, 1 over 1 plus x squared over 9, which takes care of the coefficient because this guy needs to be 1. Now this guy needs to be a minus. So 1 over 1 minus x squared 9. Okay. This is the frog that we put into our series. We have 1 over 9 series as n is equal to 0 from 1 over x squared raised to the power of n. We can split this up and make it nice. I'm not going to do power series on it. Like you can do the ratio test on this just like you would with any other power series, and we've done a lot of those. So I'm going to move forwards. You have one similar to this one. Say you have x over 9 plus x squared. What do? You want the power in the denominator to decrease so that you can apply your previous power series. We get powers in the denominator to decrease with integration. If you integrate, You get that. We already know what this series is, though. We figured it out before. So we can just plug that in. We took the integral to get there. We have to take the derivative to get back. It's not going to be an equal sign. So we're going to take the derivative. Constant, constant, which just leaves x. If we take the derivative of x, then we're going to have 2 to the n come down, x to the 2n minus 1. The c goes away because it's a constant. And that's the power series for this guy. Yes, absolutely. Okay, so we already figured out this guy. I know that this guy, yes. This guy is equal to this guy because of the regular stuff we've been doing since forever, right? You have to understand this step to kind of move forwards. But if they're equal, that means that they're equal. You can deal with them like regular variables. So now we have this guy. I want to get rid of this power of the denominator. It makes it hard to do the regular shift things around, move x over stuff. So I take the integral of it. If I take the integral of this guy, I have to remember to take the derivative later, otherwise I've changed my value. So take the derivative later. You can take the integral of this guy, and you're going to get this function right here. This. We know what this guy is because he's right here. He's a series. So we can plug in our series. We've done nothing else. We went from I integrated, and then I found a value that I already had, and I know it's a series, so I plugged that in. But my series is just a series. N is a number because I'm integrating with respect to x. 1, -1, n, 9, all of these are constants, so I ignored them. I'm really just taking the derivative of x to some number, which you guys know how to do. So if we take the derivative of x to 2n, then the constant comes down, like so, and we subtract 1, like we've always done. The c goes away because it's a plus constant. If I take the derivative of a constant, it goes to 0. So I had a 1, 9 over here, and I pushed him in. And so it's 9 plus 1. Does that answer your question? Any other questions? Okay. That's good. So, okay. Let's do, what else did you guys have to go through? Okay, so you're supposed to find a Taylor degree polynomial. That's something you guys are required to do. Find Taylor polynomials of degree 2. So, find Taylor polynomial of degree 2, where a is equal to 9, and f of x is equal to root x. Well, f of x is equal to root x. F prime of x is equal to 1/2 x to the negative 1/2. Okay. You know that Taylor series is equal to, yes. Slightly different form than what you've seen, but it's the same thing. I'm using i's instead of n's because I want to be able to plug 2 into my n up top. So Taylor polynomial of degree 2. Go from 0 to 2. F of I, 9, I factorial, x minus 9i. We want to figure out where things are. I know my a is going to be equal to 9, so if I plug in 9 here, I'm going to get 3. Plus, if I plug in 9 at any other location, I should get 0. So then it would be, I'm going to do it by hand. I'm not going to look. That's not helping me. So I need to plug in my points, right? So I'm going to have to the 9 over 0 factorial, x minus 9 to the 0 plus 1/2 9 in the bottom, and then it's going to be over 1 factorial times by x minus 9 to the first, and then it's going to be 1/4. If I could draw numbers, that would be fabulous. Negative 1 over 4 to the 9 3/2. And then that would be over 2 factorial plus 3/8 9 to the negative 5/2 over 3 factorial times by x minus 9 to the 3. That should be sufficient. You plug in like you always have. Plus dot, dot, dot. And then you get 3 for the first one. This goes away. This is 1. That is 1. Plus, you have 1/2 root 9. X minus 9 for your second one, minus x squared over 8, 9, 3/2 multiplication. You can simplify that as you wish. You'll get 3 plus x minus 9 over 6 minus x minus 9 over 2. 2, 1, 6. This is your Taylor degree polynomial. It'll approximate your original function, which in this case was f of x is equal to root x. And that's pretty cool. And I think that's the extent of what Calculus 2 is for you guys now. So, questions about that? Okay, so at this point, it's 15 minutes till the end of session. We start at 3:30. It's 15 minutes till 5:30. So please pick up your trash. Please be kind. Please, this is it. If you have any questions, you can come up here and ask. I'm sure there's plenty. Or not. Either way, I appreciate you coming. Please do the survey thing that Sark wants you to do. You have to scan your QR code thing there. So, thank you.